Hi everyone, let's get started. So thank you so much for joining our first virtual workshop. This is the first of a multi-part webinar series. Today you'll learn how to develop and deploy a computer vision app. Before we get started, please make sure your laptops are set up to follow along during the walkthrough tutorial. If you haven't done so already, please take another look at your emails for the device setup instructions. We've allocated a few of our engineers to answer questions along the way. So if you have questions, just submit them using the Q&A button in the Zoom application. In an effort to ensure optimal focus during the webinar, we've disabled the chat feature. So if you have any questions or have additional thoughts, feel free to join our Discord channel. We're pretty active there. And finally, we'll spend 15 minutes at the end to answer a list of selected questions live. So stick around for that. And without further ado, let's get started. I'd like to hand it to Marty Beard, the Chief Executive Officer of alwaysAI. Marty?
Yeah, thanks, Komal. Hi, everybody. So we're super excited to go through this webinar today. And the reason is, we're here to talk about computer vision. And computer vision is a super important and very powerful new technology trend. We all know about it. And part of the reason is it sits right at the epicenter of several new trends, right? So obviously the Internet of Things, all the edge devices, machine learning, and specifically deep learning, and big data are all coming together around vision. And that's why so many of you have registered for this webinar, and why we see so much interest week in and week out is because vision is clearly, it's the fastest growing part of artificial intelligence. If you look at the AI market, whether you're looking at robotics or you're looking at the big data aspects of it, computer vision is far and away the fastest growing part, growing at least 40% year over year. And where it really gets exciting is when you talk about the edge. Again, you could call this IoT, or you could just call it the edge. Anything connected out there in the world that is able to be made, quote, smart, to become a learner, to be able to see, to be able to act, and provide us new insights and information. This is enormous untapped potential. In fact, when you size that market of edge devices, and I'm excluding mobile devices when I talk about this. These are just sensors like cameras, drones, transportation units, wearables. When you look at all that, there's at least 4 billion of them that are able to handle deep learning algorithms like we use in computer vision. And if you add up all of that edge potential, it's actually bigger in terms of processing power than the cloud. So this is something that's waiting to be used, and something that more and more companies obviously are seeing vision combined with the edge as becoming something that they need to embrace and something that can give them competitive advantage. And since alwaysAI started, we've seen just a phenomenal amount of innovation across a wide variety of industries, whether we're talking about smart cities, or we're talking about manufacturing, where they might be doing asset and defect detection, or we're looking at retail analytics. Even if today that really means assessing social distancing, or agriculture, where you can look at crop analysis, or construction sites where they want to make sure that their employees are safe, or basically just corporate campus security. But there's just on and on a millions of use cases out there. And frankly, we can all see that this is early, but it will rapidly become best practice. So you, the developer, you're the folks that are going to make this happen. And you're the folks, and the reason that we exist as a company, to help you really embrace computer vision and help us change the world. Let's go to the next slide. So I'm just going to spend on one slide here. Let me just lay the groundwork for the basic parts of the alwaysAI platform. And again, everything that we do is for you. It's for the developer. It's for the person who wants to create computer vision applications. They want to actually deploy them. and do something with them out on the edge. 3 parts of what we do. Number one, we have a set of starter applications and related computer vision models that we've brought together, again, to help the developer get going very quickly and embrace what we call the core computer vision primitives, whether, image classification, object detection, tracking, counting. We're going to get into those details today as we get into the workshop. But we work really hard to come up with starter applications that we think are the ones that you, the developer, really need to get going. We also have a set of over 60 computer vision models. These are high quality models, pre-trained models that we've sourced, again, that we think will let you get going as quickly as possible. But we've also created the capability for you to add your own model, right? So we understand that many of you are already working on a model. It's more, what you really need to do is customize that and get it executing out on the edge, and we can help you do that. Number two, we have a very rich set of APIs, and these are really to help you customize your application. So we know that you want to get going. Computer vision without a platform like alwaysAI is very complex. Lots of different frameworks, lots of different languages and libraries you need to learn, and then of course lots of different endpoints. So we've brought together a rich set of Python APIs. We're a Python environment, which make it easy for you, whether you're a beginner or an expert, to customize and extend your application. And this, simple examples are, you want to rotate an image, you want to crop an image, maybe you want to blur a face, or you want to add a different accelerator, whatever it is you want to do. We continue to add APIs to help you do that. Now, third part is really, the endpoint, right? So you've used our starter apps and models, you've customized your application, and now you're at the point where you want to deploy that application and get it working. This is the exciting part. You want to get it out to that endpoint. As long as that endpoint is an ARM-based, ARM32, ARM64, basically within the ARM cortex, as long as it's there, we can get your application out to that endpoint, as well as obviously your host machine, whether it be a PC or a Mac. So again, we've brought this together. These 3 parts are always thought of as a holistic platform. And we've designed alwaysAI to be very easy to use end to end. And so what I'd like to do now is, with that kind of grounding on why we're all on this call, because we know that computer vision is the future, and a little bit high level about our platform, I'm going to turn it over to Steve Grisette, my co-founder and chief technology officer, to walk through the actual workshop. Steve?
Thank you, Marty. Hello, everybody. So first of all, I want to do a little bit of preamble work here and before we get started. So this workshop is really an overview of our platform and how to develop applications with it. The other thing is there's an assumption that you guys have installed the development environment local on either your Windows or your Mac PC. And if you haven't, you can use the QR code in these slides to go to the site and get yourself set up. So let's begin and start an overview. So our platform has 2 workflows for developers, and the first one is the local workflow. So this is where you develop and test your applications locally on your Windows or your Mac PC. Then the other workflow is where you develop an application again on your PC, and you can do some testing, but then you want to go ahead and see what it's going to look like on that edge device, or single board computer as we've called it on this one. And you want to make sure that it works and operates there. So we support both those workflows within the platform. Next slide, please. So we really have 3 third-party software components that our platform is based upon. And the first two are Python and Node that work on your development PC. And so the good news here is when you run our installers for Windows or the Mac, it will go ahead and put those environments in, so you don't really have to worry about those. Now, when you're working out on your edge device, you need to make sure it has Docker, because what we move back and forth is a Docker image. So you have to have a Docker container in there to pull it in. Now, in our guides, we have a get it started guide in our docs, and that will tell you how to install it on the machine. So for example, if you have an ARM64, you should go ahead and look at that type of device, an ARM32, Raspberry Pi, etc. And it'll tell you how to do that. Next slide, please. All right, before I get started on the actual application development and using our platform, I just want to go I want to go over the primary machine learning, what we call primitives or core machine learning concepts within computer vision. And what I'm going to do right now is I'm going to stop my video and share my screen, because I want to do it via a demo, because I think that's a little bit more effective. So we stop. All right, so the first one we want to talk about is classification. And within classification, hold on, I'm adjusting my screen. It's always fun to do things live. Within classification, what classification does is it finds the primary objects in an image and classifies them. And here now, let me run it live. So here we see that the primary thing in the image is the water bottles. And so the classifiers find that and classify the water bottles. But what this thing doesn't do is tell you where the object is when you run a classifier in the image, or it ignores background. So that's two components in this. So some of the practical applications, well, we've done a lot of college hackathons. And so a lot of people have used classifiers for something that's pretty obvious here, for trash sorting. So you can go ahead and see like plastic bottles, different type of bottles, and you can send those to recycling and so forth. Other applications of classification are in the medical world. So if you have a slide that you check a slide to see if the cell contains malaria or not malaria and so forth. So those are some of the examples of what classification can do. The next primitive I want to talk about is object detection. So object detection classifies things in the image, but it also will give you where it's located. So hold on, let me get started here. So you can see I'm running this in real time. So what the difference is now is what object detection is going to show you is this is where that object is in the image. And this has a lot of uses out there. And one of them is right here, I'm identifying and because I know where they are and I know the number, I can actually count bottles. So if you think of a smart city application, in a smart city scenario, you could put it up on an overpass and count cars. If you're doing an autonomous vehicle, you can know where an object is and avoid it. And look, for example, a security camera, you can detect when something moves in and out of that security camera's vision. The next one that we're going to talk about is semantic segmentation. In semantic segmentation, you go ahead and classify every pixel in the system, and you also detect background. So both what I didn't mention object detection, it also is taught to ignore the background. And so in this case, what we're doing is we're detecting the water bottle on a pixel level and the background. There are techniques to smooth that, and we cover those in the blogs on semantic segmentation. Also, on this one, we're using some of our APIs that allow you to filter by object type. And so we're filtering bottles and then sending any other pixel detections to the background, and that is explained in our API guide. Now, some of the practical applications on this is what your autonomous cars will use. So because you're getting the background, because you're getting every pixel classified, if you have a depth camera, you'll be able to get back from the pixels the distance and so forth, and that's pretty important in autonomous vehicles. Other usage, because it does at the pixel level, is things like in healthcare, looking at an X-ray. So it's very good at analyzing X-rays. The other piece that we've seen it and heavily used in is in mapping things. So if you have a satellite up, for instance, you'll be able to detect, where cities are, where agriculture are, where villages are, things like that. So it's very effective in the mapping for either drones or satellites. So finally, the third and final one is instance segmentation. And instance segmentation is pretty interesting. So it combines really two techniques. It combines using an object detection and a semantic segmentation. So it's not only going to detect the object. Let me go ahead and start this so you can get an idea. It's going to uniquely find an object and set a mask to it. So as you can see here, not only am I detecting the bottles, but I know the uniqueness of the bottle. I have my two bottles, so you can see the different colors and you can see the masks around them. Now, this is pretty popular for using things like inventory analysis from a camera so that you can see what your inventory is. It's also used in warehousing for picker programs so that you can use, again, that point cloud methodology with a distance camera, and you can train the robot arm how to grab and handle devices or handle objects on that. The last thing I'd like to say on this one, it is expensive to do this. You're making several passes across the image. So where we've seen the other ones, they're in milliseconds, and at the most, 100 millisecond, low 100 millisecond range. This one's going to actually take, over a second to process through the inferencing engines that you'll see on edge devices, including your PC. So, so it is expensive to do, and so you need to keep that in mind when you're doing applications. All right. So now let's start to move into the meat. Well, so let's start to move into the meat. So the first thing I want to do is show you what we're going to develop. And so I'm going to come in and show you the application here real quick. Okay. So we're running. And what we're going to develop here, go full screen, is a facial detection system as we go through this webinar. So what we're going to start out with on the process is we're going to go ahead and take a look and figure out how to deploy a generic object detector trained on detecting over 20 type of objects. The next step we're going to do is I'm going to teach you how to use our APIs to filter on results. And this is pretty common. You don't want to see 20 objects. You want to see maybe a couple at most. And I'll show you how to use that API in our system. After that, what we want to do is take this generic object detector, and then what we want to do is change it over to be a specific type of detector, and in this case, a facial detection. And once we transpose that system now into a facial detector, the last piece I want to do on the workflow is go ahead and deploy to an edge device, and then show you how to use an accelerator with that edge device. In this case, I'm going to use an Intel accelerator today to plug into a Raspberry Pi 3. So let's get started. So it's important when you start to run the tools and so forth to make sure you're in the directory where your development applications are or the application you're working on is at. So I'm going to go ahead and go into our starter apps, and specifically our real-time object detector. So give me a second here. So now we're here. So the first thing to really set up my project, I need to run our command line tool set, which is our alwaysAI, and I can invoke that by typing AAI at the command line. So the the CLI, or command line interface, I'm going to use CLI as we go forward, is really divided into two main command sections. One is a user command section. So what that basically allows you to do is log in and log out, and then you can show whether you're logged in or logged out. This is important when you're trying to grab assets up on the web. You need to be logged in. So if you're grabbing a model and you want to download that piece, you need to make sure you're logged in. So I always like to start out by going alwaysAI show to see if I'm logged in. And it says bad command because I missed the user after I told you to use that. All right. And there we go. And we can see now that I'm logged in. The other set of commands are around the app set. Having typing skill troubles here. So anyway, on this, it has your different commands that you're going to need to do, like install. You can shell out, start, add a model, remove a model, and so forth. So that's a brief run through on the CLI system. So now let's go ahead, and we're running locally. And so what I want to do is take this object detector, and I want to see what's going on with it. So I'm going to go ahead and deploy this object detection application. And I do that locally by typing the word install. And what install is going to do is load a model in and create my Python virtual environment with my application. So now I've done that, and now I want to start the application. So what you need to do is type in the start command for that. And then we're going to transition to our streamer, which is our, we have a web server that outputs to a web page, and that's called our streamer when you look at it. So we've been doing that. So here we go. This is the object detector looking, and say right now it's finding in my background a TV monitor, and of course it finds me, and I'm really happy that it thinks I'm 100% a person. So it's nice to get that affirmation from a computer. So that's the basic object detector. Now let's go through and take a look at the anatomy of that program. So I'm going to bring up my favorite IDE, which is Atom. You can use any one you want. We're not tied to that. So if we start to look at this application, it's a typical Python application. And the first thing we want to do, and you want to make sure anytime you're working with alwaysAI, is that you import our Python libraries. And those will give you access to the APIs and then any type of middleware. I do want to say, not only do we have Edge IQ and our middleware in there, but for people working in computer vision, we also have libraries like NumPy. We have libraries like SciPy. We have libraries like OpenCV that are in the middleware components. And then we also have dlib in there. So you have your full suite of things here beyond just Edge IQ, alwaysAI stuff to work on in the platform. This, of course, so the other thing is I'm just importing a standard Python library on it. So now let's go into the main piece. And what I want to step back and say, if I were doing semantic segmentation and things like that, the format of this, of what I'm going through right now is pretty much similar. So the first step thing that you want to do is create an object detection detector using the object detection class. And so that's this system right here. Now, part of it in the core parameter is a model. In it. So you're going to reference the model that you want to use. And in this case, I'm using one from the alwaysAI catalog. If you had a private model, it could say Jane Doe here or Acme. The next thing is the model itself, which is MobileNet SSD. Going down from that, after we do the instantiation of the object class, the next thing we do is we go ahead and we load the model into the inference engine. And in this case, one of the parameters we define is the engine itself. And this particular one is going to use the CPU to do deep neural networking. This is just kind of giving us some of the stats on the stuff like the model ID, what accelerator we're using, labels, and so forth. The next thing we do is we do have a lot of tooling in our API. So I suggest you go through that. And one of them is a frames per second detector. And so when you're in development phase, you often want to know what's the frame per second for my application. And so we're initiating that function right here. Now comes the main work of the program, and that's the try and while loops. And the try loop we set up, or the try statement we set up, we're going to really do the video portion of our application. So the first thing is we want to, again, create a class for the video web camera stream out of our Edge IQ library. So that's what we do here. And then we want to ship the results to our streamer. And that's our web services system, or our web server that's piping things out to the web browser. Now, here's where I use that Python library. And it's important to do this. You want to wait and let your webcam warm up. And you also want to start your FPS meter. Okay, the main work of the application is done in the true loop. And what happens here is we grab a frame from the video stream. And then what we want to do is run it through the inference engine for object detection. And key parameters here are the frame itself and then the confidence level. So we're looking at here any predictions that come out that are 50% or higher in this case on it. So the next thing we do is we return the inferencing piece to a results objects. And that's, let's go ahead and take a look at that because that's pretty important. So we're going to go back to our web and we're going to go into our docs. So talking about our docs, there are really 5 important segments in the docs. The first one is the getting started section. So if you haven't set up your device, or you want to know how to set up an edge device, this is the sections you go to as some basic tutorials. When you're in heavy core application development, you want to go through these sections because this really tells the developer and has detailed instruction on how to do things like image classification, object detection, but even beyond that, how do you load an image from a file and so forth. The next set of commands are when you start to work with your models and you start to insert custom model pages and so forth. We are going to be introducing the product model retraining, and this is where these become more important. The fourth segment is the Edge IQ API. So if you don't really, once you get to be a strong developer, you don't want to go necessarily through all the verbiage of the other section on how to do things. You come here for a quick refresher of how to use the API. And then the last section is the references. So we talked about starter apps. If you go in there, come on, there we go. And it tells you all about the different starter applications that we have and then how to download those to your computer. So what we wanted to do, though, is take a look at what the results object looks like within the object detection. So let's go over there and take a quick look. So what you're going to return in this object is the duration property. So how long did the inference take within on that frame? And the next thing is a set of predictions list that comes out. And then what we want to do is take a look at that prediction list and see what the format is on each one. So what you're going to see in the object detection prediction list is you're going to get back the label, what is the predicted object in the image, an index into that label list. You're going to get a bounding box back, and then there's all kinds of properties associated with that you may want to use. So for example, one of the popular ones is, compute the distance that you're seeing out there on social distancing is to compute the distance and so forth. So that's an interesting thing and to use for bounding box pieces. So the last thing is the confidence. What is the confidence of this of the model on the detection it's made? So let's go back. That's a lot, but let's go back to our application and go through the rest of it. So, okay, so we've seen the results, and the next the next useful utility that we have is Markup Image. And what Markup Image is, if you see the bounding boxes and all the text and so forth, what this function allows you to do is mark up that image for display on our streamer or your web page. And so what you have here is really the parameters. You need to pass it your predictions property from your results object. You can go ahead and attach colors, or you can set up your own custom colors. We have default colors with this. And then, of course, the frame. And then this will pass back the frame all marked up. Now we get into what we want to put in our streamer. And if you notice, the streamer has information that comes in on the left side, which is really helpful when you're in development mode. So here we're just going to go ahead and do the text for that. And basically right here, we're just going to describe the model and the result objects. And then we're going to loop through the predictions and get the labels and the confidence for that. Send it to the streamer, update our frames per second. And then if you've been watching, I've been pushing the little red button on the left corner, and what we're looking, that breaks your streamer. So it's going to be looking for that break to see if I'm pushing that button or not right there. And then it will, of course, loop back through at that time. And then we just have code cleanup after that. So now, as I said in the thing, the next thing we really want to do, and to make this useful, and something you'll probably do with generic models, is want to go ahead and filter the results. And then you want to filter by the class or object type is what we want to do here. So let's go to our APIs and let's see whether we can do that or not, whether our APIs support it or not. And the best way to kind of find that out is to go ahead and just do a search. And I'm going to go ahead and search for filtering. And when I come in, I get really two major results. We have a filter predictions by area, and we have a filter prediction by label. And this is really the one I want, but just because it came up, I'll talk to you a little bit what filter predictions by area. So if you notice the bounding box between me and the TV, it was much larger because I was in the foreground. And the bounding box behind me on the TV monitor was smaller because it's further back in the picture. So the idea is, by filtering by area, it can either detect, you either can filter things in the foreground or background of your detection. But let's go into the one we really want, which is by label. And let's go click in that and see how to use that. So as you look into these, we describe how to use the API, and we show a snippet on it. So, and then what parameters need to come into it. So in this case, on using this filter, we see that we can the input is the predictions property list, and then the other thing is the string of labels that you want to filter against. And then the other piece is what it's going to return me as a new prediction list. So let's go ahead and the easiest thing, and so you don't have to endure my typing skills, we're going to go ahead and copy this and move to our application. So let's bring up my IDE. And so as we remember in the framework, the work's down here, and we get our results here. So after that, the key place to where we want to go ahead and filter. So I'm going to go ahead and paste this in. And I know that I have to send those results back, those predictions somewhere. So I'm going to go ahead and type in what I'm going to send it to is a filtered predictions list. So I'm going to go ahead and spell and do that. The next thing I want to do is just a little code cleanup. I don't want to go, it's hard to read if I don't make some changes here, and Python people like to do that. So that's pretty good. So now I have everything set up. Now I want to make sure that I have the right parameters. So we know this is results is the object, and I need to tap that property on it. So I need to come in here and say, I want results, yep, predictions. The next thing over here is I don't really want to take a look at apples. I just want to take a look at people. So what I'm going to do is go ahead and take a look at doing just persons. So now I need to make sure that I now have a new predictions list. So I need to make sure that I reference that throughout replace these result predictions with the filtered predictions that I have in my application. So I'm just going to go through and do that. If it was a big program, I would go ahead and let my IDE do it, but I'm going to go ahead and just show you where to do it. All right, there's your filter predictions, and then you're going to come back here as you loop through the text for the streamer. So here we go, and paste that. So now I have this new application, but some of you may be wondering, well, how do you know what to do on what was that model really showing? What was it detecting? I'd like to know. So the easiest way to do that is, again, go to our APIs, but in this time you want to go to the model catalog section. So if you're on docs, you move to model catalog, and what you can see details on the model. So we know we're running a MobileNet model here, and so I'm going to go ahead and do a search for it, and it's going to come up with a set of MobileNet models that are in the catalog. MobileNet is an architecture for a machine learning model, but I'm going to go ahead now and want to look at the details on the MobileNet SSD. And if we see down here, if I want to know, I can move through the different things. There's specs, there's all kinds of things going on with this model, but more importantly, it's labels. So here's on this one, it finds 20 things and ignores the background because it's an object detector. And here's the different objects or classes that it will look for. And person, of course, is one of those. So now let's go ahead and redeploy that application and see what happens. So we're going to go ahead, and I need to find my command line. There's my command line hiding there. And so what I want to do again is follow the process we did earlier and go ahead and install the application because I've made changes. So there you go. So now we've reinstalled the application and the model was verified to be in there. And so now we want to go ahead and restart that application to see what our changes did. And we start. We go back up and we want to look at our streamer output. And what we're going to see now is, if you notice, it's just filtering on people. And what not happening, I can move this direction. Sorry, I got to move. And you can see it's not picking up anymore on the TV monitor. So it's only going to pick up results on the person. And like I said, this is a very helpful technique as you start developing out your application for object detection. So now let's go ahead, and the next thing we want to do is really transform our application from a generic object detector around 20 devices to being something specific like facial detection. And you do that by changing what the model does on it. And so what I want to do is move over and do facial detection. So I'm going to move back into the model catalog. And so then what I want to do is find a model in the object detection area that does facial recognition. So I'm going to type in correctly face, and it's going to come in and it's going to show. And like I said, I want to find it for just the object detection. So I'm going to go up here and filter down my results. And the first thing I see right here is this ResNet facial detector, pre-trained facial detector. And I'm going to go take a look at that. And I want to make sure on the labels, yep, face and background. And then down here on this other one, it'll say similar types of models. But what I want to do is then introduce this into my code and my project. So the example of where you want to do and how to use a model is up in this little box up here. And how you introduce in your code, which I'm going to start with first, is really putting this element into your code. So I'm going to go ahead and copy it. That's as simple as you have to do. So you don't have to type if you don't want to, and come back to my application and say, we know that when we create the object detection class, we also load the model. So that's the element that the parameter that I have to change out. So I go into my object creation, and I go ahead and I paste that new model in there. So now this is from the alwaysAI catalog, and it's a ResNet. And so I want to save that. But then I also now know that I'm filtering for people and I'm detecting faces. So I need to go kind of undo down in that while loop what I'd done before. And the easiest way to do is just simply comment that out of your code. And so I'm going to do that. And then I know that I've spent, I changed all the result predictions to filter predictions, and I want to move those back. So I'm going to come in and say result predictions, go down there and put that in. And then I know my secondary loop is down here where I'm talking to the streamer and going through those is down there. And I'm simply going to type in results dot predictions. And so then now I know that we have it set up. So I'm going to save that. And so now I have my application piece done, but there's a second piece you need to do. You need to add the model to your project. And that's what this code up there does, using our CLI command to add the model. So I'm going to go ahead and copy this one and then go back to the command line. So go ahead and find that. It's always fun working on one screen. Okay, so let's paste that. So now we're going to add the model. So we go through and we do the model piece. So now we've added the model. I could easily remove, using the remove command, I could get rid of the original MobileNet model if I wanted to. The next thing I want to do is, now we've made a change to both our application and our project. So I need to reinstall that, both the model and now the application into my virtual Python runtime environment here. And so I use the CLI command to do that. So now we've installed. So now let's go ahead and let's run this application. And so everything seems to be working. Oops. See, I got an error in line 41. So there we go. So this is, you can tell this is real time. So I'm gonna go see what I did wrong in line 41. So, okay. So I believe it's results is the correct thing, not result. So let me change that and save it. And now I'm going to have to go ahead and redeploy it. So there you go. All right, so let's go ahead and we're going to have to install that again because I made a typing error. And then we're going to go ahead and start it. And this time, because I did things correctly, it's going to work. And so now we have a facial detector. So we went from a generic object detector that was filtered by on persons to now a facial detector. And then again, what I want to do is I'll just bring a book into this, right? So here we go. This is a book of Richard Feynman. And so we have Mr. Feynman in there. It's getting in my way. There you go, two faces on this. So there you go. Now we've built our facial detector. So as the last step in this exercise, what I want to do is show you the remote workflow. So how do I get out to my edge device, and what does this look like running on a Raspberry Pi 3? And so that's what we're going to do next here. So first thing I want to do is, and I'm going to see if I can get my control because I do want to show you something. So there we go. So I'm going to start my video again. And hopefully you can see this. I'm going to make sure I get it right. But what I have right here is an NCS2, an Intel accelerator they can buy on Amazon or on the Intel webpage or other e-commerce web pages. And it's simply a system that you can plug into a Raspberry Pi that offloads the deep neural network from the CPU onto Intel's Myriad processors. They also sell these as chips, and they're often put into applications. So let me stop my video. And let's go and see, first of all, how do we access that in our code? And let me reshare. I think my screen is still being shared, so that's the good news. Let's see how we implement that into the code line. So again, as we said, for application developers, what we're going to change is the engine and accelerator. So we're going to come into this section. It gives you a lot of detail. We're going to find out specifically. So we click into the engine set, and we can see right here, this is the Myriad. And so what I need to do is set my engine up to be dynamic network using the OpenVINO backend. So going into my code, I want to make a change to that engine load section we talked about. So I'm going to come in and I have my application. And so right here on the load section, I'm going to go ahead and add OpenVINO to it. So there we go. Now we have that. So I need to save my application. Now I need to go to the command line and actually deploy to my device. And so it's a different workflow. So instead of doing install, I first have to target and then deploy the system. So how you do that is you come in and do alwaysAI app configure. So you run the configure command. So the first thing it's gonna ask you for is, what is the username and host name that you're gonna execute this under on your edge device. So being a Raspberry Pi, we all know that's Pi. And then the IP address for my system, I type in next, be different for all of you. So we go ahead and enter that, connects to it via I hope by SSH. We'll see, we're struggling a bit here. I may have to do some quick troubleshooting, timed out on connection. So let me make sure that my device is there. I'm gonna go out hopefully and check. These are the fun, like I said. So let me go ahead and do something and see if my device has changed. So I think it's probably moved to 14 or 10 on me. So let me go ahead and check that. I'm going to go ahead and see if that is there. We're going to assume it's 14. So let me go back and like I said, these are just some of the fun things that happen during live demos. So I apologize on that, people. And let's go ahead and deploy. Doesn't like that one. So the other one was 10. So let me go ahead and do that. Otherwise, we may have to skip this, and I apologize. We have some technical troubles. All right, so I apologize on this piece. I can't show you how it's going to be deployed on this. So I may have to come back on that. So let me try one last thing, unless maybe I type something in it. I'll check an SSH myself. You're getting troubleshooting. Oh, yeah, so. It was on this morning when I checked it. I just want to, yeah, okay, so it's there. So I must have mistyped. So I will be able to show you this. Okay, there we go. Checks the SSH, checks whether the Docker executable is there, asks you where to build your directories. And the next step I want to do is deploy. And again, my apologies on that. I obviously mistyped someplace on that. So I appreciate your patience. So we come in and now we're deploying. We've configured and established where that device is. We're now going to copy the application to the target device. We're going to build out our Docker image. And so we're going to pull that into the container. And then the next step we're going to do is pull in our models. We're going to create our virtual environment. And then we're going to go back to our good old start. Takes a little bit more time because we're running on a remote device now. So we come in here and we say, okay, let's see what's going on. And there's my Raspberry Pi, and I'm going to try to move back in. There it goes. And let's see if I can bring my book back in, whether it detects that. And there we go. Now we've deployed it and we're using an Intel accelerator. And that really comes to the end of my tutorial today. And what I'm going to do is stop sharing and turn it back to Marty for Q&A and announcements.
Okay.
So Marty?
Yeah, thanks, Steve. Okay, great. So, we wanted to do a live demo so you guys can see it in action, see how to create something and get it out on the edge, and look at some of the capabilities and flexibility that the platform brings. But really what we would encourage people is, identify a project. I mean, if you haven't, it doesn't matter whether you're a hobbyist or a student or you're working in a company somewhere, vision can add an amazing new element to your application, solve a problem in a new way that maybe you haven't been able to leverage. So we really encourage people to think about that. What business problem are you trying to solve, and how can computer vision help you? We've been at this for quite a while, working with just an amazing amount of just diversity across developers and industries. So reach out to us. Let us know how we can help accelerate your project. We love getting into the weeds, and our engineering team and our biz dev team, and we're all here ready to help you out. The other thing that you can do is engage with other developers through our Discord community. So many of you out there, in preparation for the webinar today, you've already joined, and we can see you active, which is fantastic. Also seeing just a amazing amount of great questions coming in during the session. But join our Discord community, engage with other developers, get some great ideas, and so forth. Last thing I would mention is our blog, which is at alwaysai.co, our main website. We really try hard to put in some great how-to guides, tutorials, testimonials, case studies, etc. on our blog to really just to help get you going, give you some ideas about what you can do with computer vision. We are going to continue rolling on this webinar series. Our next webinar will be on May 20th. So we will do these approximately about every month. And that one's going to be on pose estimation, so-called human pose estimation, movement on the edge. So that would be an amazing webinar. But before we drop, there's been some great questions that have come in. So I'm going to turn this back over to Komal, and we'll spend some time answering.
Thank you, Marty. Okay, so we've received a lot of really good questions throughout the webinar, and hopefully you've received answers to a lot of them, as our engineers have been going through and answering all of them. But there are a few questions that we thought would be really great to answer live. So the first question is for Marty. Where can I find the pricing for the APIs? What does the pricing for the platform look like? Yeah,
so right now, it's a great question. And right now the platform, literally what you just saw demoed, is free. And we will always have a very, very strong freemium version available to all developers, which will allow you to leverage the model catalog, input your own model, leverage the APIs, and deploy on up to three devices, okay? We're going to implement tiered pricing. It'll be subscription-based, and it'll vary depending on how many people are subscribed, how many developers. For example, you might be part of a team, or you might just be a single developer, as well as the number of endpoints that you can deploy on. It's going to be, and that'll come into play in June and July of this year. But right now, freemium, and in June, July, we will always maintain a very, very strong and comprehensive freemium version, because at the end of the day, we're all about democratizing computer vision and getting this amazing technology into the hands of as many developers as possible.
Great, thank you, Marty.
Sure.
Okay, the next question is for Steve. Can I train a model with my own images?
All right, so the answer is yes. And then we will be actually releasing what we call Docker containers that will allow you to go ahead and create and augment your own classifier or object detector, and that will be coming out fairly soon from us. But meanwhile, if you need to do that, please contact us. We can share all the stuff, and maybe even set up a, at least on Discord, set up a session with you on how to do that. But yes, model retraining is one of the core pieces of our workflow.
Thank you, Steve. Okay, and the next question is, this one is for Jason. Is there any model for social distance reinforcement? Jason?
So I'll grab this one. So quickly, if you notice when I went into the APIs, we talked about bounding boxes, that it has bounding box per distance. So you could use the application I have to detect persons. And if you have a set of people, it will say there's this distance and that distance between bounding box. So it's part of the properties of one of our bounding box APIs. And so you'll be able, and I've seen these ones on LinkedIn, you'll be able to see what the social distance is from, say, a mounted camera in a store or so forth using that construction of API. Again, you need more details on how to construct that and so forth. We'll be on Discord to help you. Just reach out.
Thanks, Steve. The next one is also for you, Steve. Sorry.
That's okay. It comes with the territory.
So how easy is it to create a system around dog detection, identify them by name, and provide alerts for certain actions like moving around, getting out, or in some virtual fences? Do you have a directory of developers we might contact to help build up something like this and other applications?
So we do have some SIs that work with us, and again, either contacting Marty or Scott directly on that. They can start to lead you on it. Basically, again, you would need, I would say that I would use a two-phase model, and we have examples in our starter apps. There's an age and gender one, but you'd use a similar type of thing where you do an object detector first. And I believe we have a blog on that too. Section where you use an object detector to detect dogs, and then what you would do is you take the bounding box, and we have the API from the detector, and then you'd run that detector through a classifier that would tell you what the dog is. Now, again, the great thing about object detection, it also can tell you where something is in an image, and so you can set up what we call regions of interest or bounding box in that image, and you'd look for it when it would cross those pixel lines. So hopefully that's helpful.
Yep, super helpful. Thank you. The next one is for Eric. Are there other ways to integrate to third-party applications without using TCP sockets?
Yeah, so hey, I'm Eric. So really, it's really based on your application. The answer is yes, the short answer. The long answer is like anything you want to use. We have examples of HTTP. We have examples of using WebSockets to communicate. There are other things you'd integrate, such as like a Redis task queue. All of these things, anything you would use with a Docker container or communicating between Python apps, you should be able to use with our platform as well. So if you have any trouble getting any of those third-party libraries together, just reach out on the Discord channel and we'll help out.
Okay, thank you. The next one is for Scott. When do you plan to release a training framework?
A very good question. So soon, we have some things working in the lab and really going into beta with them soon. So, please reach out if you're interested. We're looking at a relatively small group of users to start with, and as the tools mature, the training tools mature, we'll broaden that out. So we'd love to hear from you. And I think we have another question. Let me just jump on it, Komal related, which is, help. Labeling, collecting data and labeling images is pretty painful, right? Unfortunately, it's pretty painful. So what we have is integrated with the training tools. We have some standard labeling software, some intake software, things like that. But at the end of the day, unfortunately, you like us, you still need to generate images, and you still need to label those images. The good news is that we do have some ways to collect in the field. So if you have an application out on an edge device, we have some really straightforward utilities to help collect in context information. So as your system is out taking video, you can capture some of that for training purposes. So again, shoot us a note on Discord or reach out directly, and we're happy to talk about any and all of those things. Thanks, Komal.
Yeah, thank you, Scott. One more question for Steve. How many models can I use at the same time?
So loaded question. So you could, in theory, use infinite, but I wouldn't recommend it. My recommendation, particularly on edge devices, is no more than 2. 3 would be pushing it, and there are some, like the Jetson line from NVIDIA can probably handle that. Your x86 system probably can handle it, but you probably should max out about 3. If you use that Intel accelerator that I did, even Intel recommends on a Myriad no more than 2. So.
Great, thank you. So at this stage, we will wrap up our Q&A session. Just want to let you guys know that we'll be sending out a survey after this webinar. Answering it really helps us understand what types of topics you're interested in learning about, what computer vision related topics you want to see or you want to have a workshop around. So if there's anything specific, you can always contact me, but please definitely fill out that survey, as it helps us capture a lot of important user data. I'll be sending out a recording of this webinar. So for those of you who joined a little bit late, you'll have access to the full webinar end to end, and you can see, you can follow along with Steve's tutorial. With that, I just want to say thank you so much for joining and have a great day. Bye, everyone.